What are the main principles of quantum physics for beginners? Quantum physics is making headlines as more people seek to understand its impact on technology and our universe. The question many are asking today is, what are the main principles of quantum physics for beginners? With the rapid advancements in quantum computing and other technologies, grasping these concepts is more relevant than ever. Let's break down the essential principles that from the foundation of this fascinating field. First, we have wave-particle duality. This principle states that particles like electrons and photons can act both like waves and particles. Depending on how we observe them, they can display different behaviors. This dual nature is fundamental to understanding quantum behavior. Next is quantization. In quantum physics, certain properties, such as energy and angular momentum, can only take specific values. For example, electrons in atoms occupy distinct energy levels. They cannot exist in between these levels, which is a significant departure from classical physics. Another key principle is quantum spin. Unlike classical spinning objects, particles possess an intrinsic form of angular momentum called spin. This spin is quantized and has unique characteristics, such as requiring a 720-degree rotation to return to its original state for particles like electrons. Superposition is another intriguing concept. Quantum systems can exist in multiple states at once until they are measured. For instance, an electron can be in various energy states simultaneously, which challenges our classical understanding of existence. Entanglement is a principle that describes how particles can become linked. When this happens, the state of one particle can instantly affect the state of another, regardless of the distance separating them. This phenomenon raises questions about how information is transmitted in the quantum realm. The uncertainty principle tells us that certain pairs of properties, like position and momentum, cannot be known with perfect accuracy at the same time. This principle imposes fundamental limits on how precisely we can measure these properties. Finally, we have probability and measurement. Quantum physics does not predict exact outcomes but rather the likelihood of different results. When we measure a quantum state, it collapses into one definite state, which is a departure from classical predictions. These principles set the stage for understanding quantum technology and its applications. As discussions around quantum spin and entanglement gain momentum, it becomes clear that these concepts are vital for anyone interested in the future of technology. With ongoing research and developments, now is a great time to grasp the basics of quantum physics.